Okay, here's some problems from the 10.2 practice that I'm going to choose to do with you guys. I actually have the answer key here so you can see some of the answers, but I want to explain them as we go. Okay, 15 says the arc of a corresponding to a central angle of 35 degrees in a circle and a radius of 10 feet. Okay, so it wants us to find the arc length. So it doesn't give you a picture here, which I wish it did, especially since you're just learning to do it. But the picture would look like this. Okay, this is a central angle. That's what we're creating. We're creating central angles, okay? And they tell us that this is 35 degrees and the radius is 10 feet. And what it wants is the distance from here to here. It wants that arc length, okay? So I want to do this with degrees and I want to do it with radians. So I would need to get the circumference of the whole circle and then just take the portion that I need. What's the portion that I need? I need 35 degrees out of 360. I just need that portion of the circle. And then I have to go 2 pi r. Okay? All right. And then what I'm going to do here is if I multiply all those together on a calculator, I get, and you can test it if you want, I get 6.1. My calculator moves on that, by the way. I would go 3.35 times 2 times 3.14 times 10, and then hit equals. Go divided by 360. Test it, and you should get 6.1. Okay, so now we know that distance, okay, as 6.1. Now I want to talk about, the answer that they have here. Okay, so let's take a look at the answer that they have here. All right, and well, this is the final answer. Okay, 6.1. Okay, we know that because we just did it. But let's do this by making 35 degrees radians. Okay, so 35 degrees as radians is this. Okay, that's 35 times pi over 180. All right, and when I do that, I get 0.61. All right, so just to show you that, let's write like a different way to do it. Okay, so here's like way number 1 with degrees, and then way number 2, I'll switch back to blue. Okay, so we're converting our 35 degrees to radians. And when I do that, I'm going to get, I know that that's going to equal 0.61 radians. Okay? That's going to equal 0.61. All right? So that tells me that that right there is 0.61 in radians. And now the only thing that you need to do to get the final answer is multiply the radians by the radius. So 0.61 times 10 is equal to 6.1. Seems a lot easier. Let's make some sense of it though, okay? I want to look back at the way I did it with number 1, okay? And something's going to look very, very familiar with this here, okay? So I'll switch to red. So I want you to look at this part of number 1. And I want to simplify that and show you what I get, okay? So if I go 35 times 2 pi, I get 70 pi. Try to stay with this. 70 pi over 360, okay? Now, if I were to cut both of those in half, I would have 35 pi over 180, and that should look very familiar, okay? That's our 0.61, okay? So even though we're doing it in degrees, this part is representative of the radians, and that's important to know, okay? So for 16, I'm going to erase all this stuff because it's probably starting to get a little jumbled, okay? All right, this time for 16, the arc corresponding to the central angle pi over 3 in a circle of a radius with 6 inches. Okay, so we know from the last example that all we had to do was take the radians and multiply it by the radius. okay? So you can see that's what the answer key has done here, okay? It has taken the radians and it's multiplied it by the radius, which gives us 6 pi over 3, which gives us 2 pi, okay? And 2 times pi is 6.28 inches, all right? So if just so you know, we already know what the answer is here, but if I were to make pi over 3 degrees, I would multiply it by 180 over pi, and that would give me 180 pi over 3 pi, and that would give me 60 degrees, okay? So if I were doing it the other way, I would go 60 out of 360 times 2 times pi, what was the radius, times 6, okay? And when I do all this, if math is correct, I should get 2 pi. 60 times 2 pi times 6 is 720 pi over 360, which is, in fact, 2 pi. Okay, moving on to other problems. 17. If the arc length shown is 21.3, find theta to the nearest hundredth of a radian. Here's our arc length, okay? This time we know it is 21.3. And we need to find theta. So theta is just always the missing angle, okay? And it's in radians. So think about what we learned in the last problems. When we went radians times the radius, we got the arc length, okay? So when I went theta times the radius, I got the arc length. And now I would just have to solve for theta by dividing both sides by 12, and I would find out that theta is 21.3 divided by 12, and that's how this is right there. That's 1 point. So I would get 1.78 radians, okay? And then I could make that degrees if I wanted to, because we just learned how to do that. 18. If the arc length shown is 15, find theta to the nearest degree, okay? So for this one, I would do the same thing, okay? I know that the theta times the radius is going to give me the arc length. And then I would solve for theta in radians, and I would figure out that it is 15 over 6. So theta is 2.5 radians, as you can see right here. But they want this answer in degrees, okay? So in order to make this into degrees, I would need to go 2.5 radians. And then I would need to multiply that by 180 over pi. And that's going to give me the answer in degrees. Okay, moving on a little bit further. In this picture, the measure of theta is a radian. Okay, I like these problems because this shows me that you're truly starting to understand it, okay? So the measure of angle theta is 1 radian. So they want to know if this is true or false. Well, I can tell immediately that it's false, because if this was 1, this has to be 1, okay? The measure of angle theta is 1 radian. It's false. If the measure of theta were 1 radian, then the arc and the radius would have the same length, and they're not all the same, okay? 21, if the measure of theta is a radians and b degrees, then a is equal to 180b over pi, okay? So this is a little abstract, so let's think about this, okay? If the measure of angle is a radians and b degrees, let's think of two that are the same, okay? Let's pretend that I have something that's 2 pi. What's 2 pi radians in degrees? It's 360, right? Okay. And we want to have something that is equal to a, okay? Something, I'm trying to underline. Something that is equal to a. So what would I have to do? What would I have to do to b to then get to a? Well, I'd have to take my degrees and turn them into radians. And how do I do that? Remember? I multiply by pi over 180. and that would give me 360 pi over 180, which is equal to 2 pi. So we just kind of did a proof here. You know, what did we do to B to get to A? We multiplied it by pi over 180. So we can see right here, A is equal to B times pi over 180. It's not this. 22, if the radius of a clock is 5 inches, what's the distance around the edge of the clock between 2 and 5 to the nearest hundredth of an inch? Okay, so for this problem, we have a clock that we're looking at, and we know that the radius of the clock is 5 inches. What's the distance around the edge of the clock between 2 and 5 to the nearest hundredth of an inch? Okay, well, first of all, I would want to know, you know, how big is that angle in there, okay? So how many of these would go around the side, right? Well, it's a clock. So there's 12 different sections, which means that each one is 30 degrees. Okay, so 30 and 30 and 30 is 90 degrees. Okay, so basically it's like 1/4 of the circle. And the radius is 5. What's the distance around the edge of the clock? You could do this with radians, or you could do it with degrees. But basically I know that this is 1/4 of the entire circumference. That's probably the easiest way to think about it. So I could do 90 over 360, because that's 90 degrees, times 2, times pi, times the radius. And that's going to give me, well, what should we get here? See how it's talking about it right here. That's going to give me 7.85. Or I could go 90 degrees, because I know that's 90 in radians. What's 90 degrees in radians? Well, you'll have that memorized soon. But that would be 90 times pi over 180, which is equal to 90 pi over 180, which is equal to 1/2 pi, which makes sense because it's a fourth. What would 4 1/2 pi's be? It would be 2 pi. So 1/2 pi times 5 is going to be equal to 5 pi over 2, which is equal to the 7.85 number. So hopefully that gives you a good start on 10.2 and lets you get through it. And I'll make something similar to this tomorrow for